Welcome friends in science lecture first, lesson 10 gravitation. In this particular chapter, we are going to start with Newton's first law of gravitation. Now, what is basically a Newton's law of gravitation is that all the objects in the universe attracts each other, right? So this is a basic. Newton has created many laws regarding gravitation. So he subjected what is basically gravitation is that all the objects in the universe attract each other, and this force of attraction between the objects is called as a gravitational force. That means any of the two objects, it can be a tiniest thing and it can be the greatest celestial object that is out of the earth, that big objects are there like sun, moon, other planets and other stars. These all objects are called as celestial objects, and the tiniest object present on the earth also, like a small apple, or a very small apple can also attract the earth, but due to the less gravity because of the mass present, it cannot attract the earth, as it is not seen also. Okay, it is basically, it attracts the earth but it cannot pull the earth towards itself, but the earth is very big, so it has got a big mass, so it can pull the apple towards itself. Fine. So this force of attraction between the two objects is called as a gravitational force. We have heard in many a times in stories also that an apple fell on the head of the Newton's when he was sitting below the tree of an apple tree, and he just understood, okay, why did the apple fall on his head and didn't went on the other side. So that was a basic creation of an idea about how this earth is capable of attracting the things towards itself. So any of the object is having any of the object, that means the amount of mass present has the capacity to attract the other masses. This force between the two objects is called as a gravitational force. Many of the different scientists before Newton also have tried and proved many things around, like Copernicus, Kepler's three laws are very famous. Galileo was the prominent scientist from which the Newton has done the work from. Basically, I can say that Galileo has done much work and just Newton has polished that work. Fine. So these were the scientists who has worked for gravitational force before Newton's. Now the famous law of universal law of gravitation given by Newton, that is, every object in the universe attracts every other object with a force which is proportional to the product of the masses, proportional to the product of their masses and inversely proportional to the square of the distance between them. This force along the line joining the center of two objects is called as a gravitational force. So you may see the diagram that this is an one mass which is having a capital M, having a mass of with capital M, having this center, and here is an mass B with small m, because this is a small mass, so this is small m, and the distance between the two is taken as d. So this is the d, and this force is a lining joint between the two center of the masses. This is center of mass, this is center of mass, and joining in the line towards itself. So this mass is pulling this object towards itself, and this mass is pulling this object towards itself. So this is how the line of force is there between the center of two mass. Now here capital M is the mass of object A, small a is mass of object B, d is the distance between the center of mass of two objects, that is A and B, right, and the force of attraction between the two objects is F. So we'll go furthermore. Now, according to the universal law of gravitation that we have done regarding Newton, the force between the two objects is directly proportional to the product of the masses. That means F is, this is a sign of proportionality. So F is proportional to capital M, that is a mass of object A and mass of object B. And the force between the two objects is inversely proportional to the another statement for that was inversely proportional to the square of the distance between them. That F is 1 upon d square. D was the distance between the two objects. Like combining this equation 1 and 2, this equation 1 and this equation 2, if we combine it, we get F is proportional to capital M into small m divided by d square. So here F is equals to capital G m by d square. This G is nothing but constant of proportionality. From the sign of proportionality it turns to equals to. Why? Because we have added a constant, and this constant is called as a constant of proportionality, and in common language we know this as an universal gravitational constant. Universal gravitational constant. Now this capital G is turns out to be making the subject as capital G. D square comes on this side and capital and small m comes on the lower side. So G is F d square upon capital M into small m. That is mass of object A into mass of object B product. Fine. The SI unit of G, capital G, is Nm square, and G minus 2, because F is Newton, D square is meter square, and M into M is kg. So kg square and minus 2. This accepted value of G is 6.673 into 10 raised to minus 11 Newton meter square per kg square. 6.673. Generally we take it as 6.67 only, not 3. We are not including it. So 6.67 or 6.7 also you may take it directly. 6.67 into 10 raised to minus 11. Now the importance of this force is that the force that binds us to the earth, the force of attraction, that earth is pulling us. We are an object at small mass m, and earth is a object with capital mass, capital M, mass with capital M, and has got big mass compared to us. So it is pulling us and binding us towards the earth. Almost all the objects present on the earth is binded by the earth. The motion of the moon around the earth and planets around the sun, these two orbits that we are seeing, that moon is capable of rotating around the earth, is just because of the gravitational force of the earth, and moon also towards earth. Both of them bind each other, and because of it the moon is rotating around the earth. In the same way, we as an earth rotate around the sun, and the other planets also, all the other seven planets except then earth also rotates around the sun. Fine. We have excluded Pluto, so we are not counting the ninth planet. We are taking 8 as a planet, but if we take it, then also the every rotation of other planet is around the sun is bounded just because of the gravitational force. The other thing is that the tides and ebbs that we see, the tides and ebbs of the tides that we see is thus due to the gravitational force of the moon and of the sun, that we are saying that the water is getting pulled up by the gravitational pull, and just because of it the waves are being created, the tides are created, not a big generally, and just because of the high gravity of the moon. When the moon is at the top, full moon, then the tides are very high, and if it is a new moon day, then the tides are very low, and that's called as an ebb times. Fine. Going furthermore, we are going to take an example that is 10.1. Now in this particular example, we are seeing that the mass of the earth is taken, and the mass of the earth is here. This is an example here. The example suggests that the mass of the earth is 6 into 10 raised to 24 kg, and that of the moon is 7.4 into 10 raised to 22 kg. If the distance between this is given as 3.4 into 10 raised to 5 kilometer, calculate the force exerted by the earth on the moon, and that is taken as 6.67, and can be taken as 6.7 also directly, does not make any difference. 6.7 into 10 raised to minus 11. So the mass of the earth 6 into 10 raised to 24, mass of the moon 7.4 into 10 raised to 20, and the distance between the earth and the moon and capital G value. Fine. So we need to find here about calculate the force exerted by the earth. That means we need to find the gravitational force of the earth towards the moon. So we will take this example. Mass of the earth is 6 into 10 raised to 24. Mass of the moon I have taken as small me, that is mass of the earth, that is 7.4 mass of the moon as 7.4 into 10 raised to 22. The distance between the earth and moon is given as 3.84 into 10 raised to 5 kilometers. Fine, so we'll multiply by 10 raised to 3 because we have to convert into form of meter. Fine, for calculation. And g is 6.7 into 10 raised to minus 11 because this is in meter, so we need to convert this everything. We can't keep this in form of kilometers. Fine, we have to convert. This is given constant in meter, so here also we have to take this in the form of an meter. If it is in form of kg, we have to take this also form of kg only. Now the formula is F is equals to capital G ME, that is mass of the earth, mass of the moon, upon the distance of the square between them. Keeping the values of each, mass of the earth capital G as 6.7 into 10 raised to minus 11, mass of the earth as 6 into 10 raised to 24, and mass of the moon as 7.4 into 10 raised to 22. All the three things are in multiplication, so we'll keep this also in form of multiplication. And division by 3.84 into 10 raised to 8, right, 10 raised to 8 square capital D, and multiplying with 6.7, 7.4 years, 6 here, 3.4 because square, 3.84 into 10, 3.84, 10 raised to minus 11 plus 22 plus 24, and 8 2s are 16. So this is going to go up upper side, so from plus it is going to turn as minus. Calculating all these values, we get the answer as 2.02 into 10 raised to 20 Newton. 2.02 into 10 raised to 20 Newton. So the force of the earth on moon is nothing but 2.02 into 10 raised to 20 Newton of this force. So this is our answer for this particular sum. Fine, we'll keep up till here and we'll work furthermore in the next video. Thank you.